to start here. So this is the game of life. It's not a game you interact with, but it is a game of automation. It has different rules based on these cells and how many neighbors they have. So no neighbors, you can have a cell with one neighbor, two neighbors, and so on. And they can be in different shapes, and as you progress time, the rules of the game in life dictate what the next state of the game will be, or the next state of the board. The only interactive part here is that you can progress time, or just hit play. So all of this is based off a single signal. There's one bit of reactive state here that drives this whole thing. And when clicking this button, I'll show you what it does. Open the controls. Here is the progress time button. It'll call pass time state, which is an alias for the snapshot. This is the state that's changing. There's a transformation of data going on here. That is to simplify serializing to the URL. That's not important right now. But the actually important thing is that there's only one reactive value here, last. How does that update the board? So here's the grid. The grid is the board. It iterates over rows and then the cells within the row. It'll just render a button. It'll be disabled or not depending on the state of the game. It'll be disabled or not depending on if it's a historical cell. I've removed most of the historical code for now for simplicity, because right now we're going to focus on this last value. So we're going to be hitting this button, and that changes the color between black and white. How does a cell represent itself? Because we see that there's this iteration, but what's a board? So a board has a bunch of utility classes on it, but as far as iterating goes, we are only going to care about this state. Now notice this is not reactive at all. It is important because the width and height of a board cannot change while the game is running. So if we look at a cell, nothing in here is reactive either. We have coordinates, we have some utilities. This is irrelevant to gameplay, but more configuring the start of the board. I kind of lied earlier where saying this whole game only has one reactive value that runs the thing. There is an input set of reactive values that are then cut off and ignored. For context, we have this alive getter and setter, and that is what's used here to render the button. So when we're trying to figure out if the cell is alive or dead, we're going to defer to this other getter, which uses the previous state. So if there isn't a previous state, we're going to default to false, or the manual value if we set the manual value. Otherwise, if there is a previous state, which there is after the first iteration, we're going to get all of our neighbors that are alive, and a neighbor is any of these 8 boxes around a cell. This is how we get the neighbors. We're getting the previous board and doing some assertions. This logic here is just some boundary checking for everything around a central focus cell, and then with some conditions to make sure we're not checking negative values. We don't want to check left of the first cell, for example. So going back to the cell, after we get the neighbors, we're going to use some AI. And that AI is defined up here by the rules of the game of life, and it's very simple. Basically 2 lines of code, where if a cell is not alive, it will become alive if it has exactly 3 neighbors. Or if the cell is already alive, it will stay alive if it has 2 or 3 neighbors, or it'll die. So to recap, and going back up the stack, we have encoded our rules of the game of life. We are using them here with how we've calculated the neighbors, and forwarding that back through to our alive getter. And then we are rendering that here as a class on the button, which changes the color between white or black. That button is the result of an iteration over a 2-dimensional array of cells from this board. And I can add back the history. And it's still mostly just a single reactive value, but it's a reactive collection. So again, that's kind of a lie. Every item in there is a reactive value. What that means is, since the game has loaded again, actually I should probably shrink this because the history view is kind of a lot. Let's progress time and then show history. So we have 2 history things now. I can progress time again, and we get more items through history. To fully dig myself out of the hole where I said there's only one reactive value. Like this sort of stuff, it has reactive values because it's tied to the URL, and the URL is reactive. Actually, why is this reactive? Does this need to be a reactive? It does need to be a reactive because when changing the dimensions, this board is entirely replaced. Because when the dimensions change, we can't reuse any of the same state, so we have to clear everything and start over. I wonder if I can fit this all on one screen. Yeah, no, it doesn't quite fit. This file right here is like the main screen. That is this. Just put that back to flat. So the screen down here is an individual board. So that's like just the right now square part. And determining whether or not a cell is alive or not happens from here, this getter, which then defers to this getter, which gets the live neighbors, uses our AI, which is just the if condition here, the little conditional logic, which is all AI is these days. And we have getting our neighbors logic, which is down here, some safeguarding against non-existent values. This was accessing previous here. Yeah. And this util is actually a back reference to this state. Previous is here. This is the very last history entry, and the very last history entry here changes when we click past time. Past time defers to snapshot. This doesn't really need to exist. I could probably just directly call snapshot or change this to past time. I don't know. And then this adds a new entry to history, and that's it. This is now the previous. You can make a whole game with just one value, one reactive value, and then a lot of derivation. Yeah, I don't know how to end videos. I guess I'll just play it and see what happens. See how long it goes. Oh no, that ended kind of quick. Let's see if I can get it to clear the screen. Nope. Go, 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 go. Oh no. I think if I click here, it clears? Yeah, okay. It's a good spot to end.